Hi friends, welcome to our channel. In logical models, we have two types of models. One is tree model, second one is rule model. We already discussed tree model. For example, decision tree. Now in this session, we will discuss rule model. The rule models are implemented in two ways. One is first to create a combination of letters. First to create a combination of letters. What it is called? A combination of letters is called rule. Now identify the set of instances that satisfies the rules. From the original data set, identify the set of instances that satisfies the rules and assign a class label for that rule. That is, first we are creating the rule. Based on the instances, we are creating a label for the class. This is the same approach we are used in decision trees. And in this rule model, we are using one more approach. One more approach is, first we are fixing the class. First we are fixing the class and place some set of instances on that class. Based on the instances that are placed in the class, we are creating the rules. Exactly opposite. First we are creating the rules. Based on the rules, we are generating the classes. In the opposite direction, first we are creating the class. Based on the elements of the class, we are generating the rules. This is one is called a learning ordered rule list. The second one is called learning unordered rule list. Now, come to first topic. In this session, we will discuss learning ordered rule list. Learning ordered rule list. The main idea is, what is the main idea? The main idea is growing, that is increasing the rule body. Increasing the rule body means the number of rules. Increasing the number of rules. Up to which case? Increase the number of rules such that improves homogeneity. We are increasing the size of the rule body such that it improves the homogeneity of the class. Improves the homogeneity of the class. Okay, this concept is similar to decision tree. Suppose in decision tree, if a binary split is performed, you already discussed decision tree. In decision tree, if a binary split is performed, the entire instance space is divided into two parts. The entire instance space is divided into two parts. For example, children 1, children 2. So suppose children 1 satisfies this case, children 2 does not satisfy this case. Suppose yes, no case. Similarly, in rule models also, whenever we are add a literal to the rule, similar to binary split in the decision tree, in rule list also, whenever we are adding a literal to the rule, it divides into two instances. Again, the entire instance space is divided into two instances. One instance is simply the instance that satisfies the rule. The instance that satisfies the rules. Another instance is the instance that does not satisfy the rule. That does not satisfy the rule. That is of literal and binary split, both are same. Whenever these are applied, two children are generated. Two children are generated. Then what is the difference between this binary split, that is in decision tree concept, and rule models? In this, suppose we are talking about the term homogeneity. Homogeneity means simply purity. It is measured similar to decision trees. That is, homogeneity is measured by using entropy, or by using Gini index, or by using minority class. The measurements are completely same because all those comes under logical models. Now, if you find the impurity or purity, if you want to find the impurity in decision tree, we have to consider both the children. That is, find the impurity for children 1 and impurity for children 2. We already discussed it. And last we are calculating the average weighted impurity. So in decision trees, the impurity of the particular parent is calculated by using the average weighted impurity of all the children. But the main difference is in rule list. We are calculating impurity for only one children. No need to calculate impurity for the both the children and then take average. We are calculating impurity for only one children, and especially we are calculating impurity for the one which satisfies this literal. That is the one which satisfies the literal. This is the difference between decision tree and rule model, and the entire procedure is same. Step by step we are add the rule and eliminate. That means one more point is this rule list follows separate and conquer approach. The second one is, so we already know divide and conquer approach. Divide and conquer approach means divide the entire space into different number of subsets. That means finally we are getting many number of subsets, and step by step we are perform conquer operation. It is exactly reverse to separate and conquer. Separate and conquer means I am creating a rule. Now the set of instances that are not satisfied the rule are eliminated. So you got it. I am creating a rule. Identify the set of instances that are not satisfied. The not satisfied instances are eliminated. So step by step we are eliminating the instances. Step by step we are eliminating all the instances. Finally we are getting one set of instance that satisfies all the rules. One set of instance that satisfy all the rules. That means this follows separate and conquer. Now we have two steps. One is learn the algorithm of this ordered rule list, and the second one is an example. First, to create an algorithm. Suppose algorithm rule list of D. Suppose D is the set of instances similar to decision trees. Here also we have homogeneity and label, and there we have best split. Now we have best literal. Homogeneity, label and best literal. Homogeneity results the specification of the particular rule. Label returns to which rule that particular one belongs to. Best literal, identify the best split, that is by adding which literal it creates the best split. That is the best split is identified, that is best literal is identified by using the purity. So here the same procedure. Algorithm rule list of D. What is the input? Input is some set of instances. Output is a rule list R. Now move to the algorithm. Initially the rule list is 5. Suppose, what is the meaning? The data set is not empty, that is it contains at least some set of instances. If it contains at least some set of instances, then we are generating a rule. Suppose learn rule is a separate algorithm for creating a rule. We will discuss next one. By moving to this algorithm, it creates a rule. That rule is placed in R. So that means in the data set I am creating a rule R. That is, whenever a rule is generated, what we will do? Append R to the end of capital R. That is, a rule is generated, the rule is added to our rule list. Suppose R is a rule list, our rule is added to rule list. Now our data set becomes, that means separate and conquer means we are eliminating some of the examples. So our data set becomes D such that X belongs to D, X is covered by R. X is covered by what? That is what I am doing. Suppose our D becomes X is covered by R. X is the particular instance. Suppose X belongs to D. X is the particular instance. If the instances that are covered by R are removed and places the D, that is modify the value of D. This is the algorithm of rule list. This is the algorithm of rule list. Now we will move to algorithm. Okay, this is clear. Now we will move to this learn rule algorithm. This learn rule algorithm. Erasing this one. Algorithm learn rule of D. What is the input? Input is some data set, and what is the output? Output is a small r. Output is a rule small r. Okay. So what is input? Input is a data set. What is output? Output is a rule small r. Initially I am using a variable b with a value true. Next L. L is the set of available instances. That is, step by step we are eliminating some instances. So L is the set of available instances. The set of available instances. The same procedure while we are repeating until it does not satisfy the homogeneity. While not homogeneous of D. Until not homogeneous of D, then what we are doing, whenever it satisfies, we have to identify the best literal. Suppose L is equal to best literal of D comma best literal of D comma the remaining set of instances. Whenever I am identifying the best literals, the best literal is appended with, that is, we are performing the conjunction, that is the rule conjunction operation with B. So B is equal to B and L. B is equal to B and L. Then D becomes the remaining elements, that is the set of instances that are covered by that rule. The set of instances that are covered by this B, that is X belongs to D such that X is covered by, what is the rule here? X is covered by D. Simple term. I am identifying the best literal. That means I am identifying one literal. That literal is added to the rule. Suppose initially I am creating a rule as B. Initially the value is true. That means it does not contain anything, and I am creating a rule. Whenever a literal is added, that is added to the B. Now the D becomes the set of instances that are covered by the rule. The set of instances that are covered by the rules, and the set of available instances are updated. Okay, the set of available instances are updated L such that L dash belongs to L. L dash belongs to L, where L dash use same future as L. L dash use the same future as L. That means the value of L is updated, picking an element from the set of instances and remove the elements with same L and L dash are same. That is, the available instances are also updated. This is the end of the while loop. The entire procedure is completed. Now what is our step after creating the loops? After creating the rules, we have to create a class. Suppose C is the class, label is the function that defines the class. C is equal to label of D. Next, if B, that is if B exists, if B is exist, then class is equal to C. We are labeling as C. If B exists, then class is equal to C, and that is completely assigned to R, and this information is completely assigned to R. Finally we are written R. Okay, this is the learn rule algorithm. The procedure is very simple. Step by step we are finding the literal, and check the non-homogeneity. Whenever it does not satisfy the condition, comes out of the loop. Finally, we are creating the label, and this is the rule. If B exists, then the class is C, and that is placed with R. Finally, we are written R value. This is the way to create learning order list. The concept is very simple. In the next section, we will discuss an example of how to construct a learning order with an example. Thank you.